Welcome to the video on geometric sequences and series. A geometric sequence is unique because it has a common rate, so each term is being multiplied by the same thing to get the next term. So in this first one, it's pretty obvious that the rate is 2. Because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. In the second one, the rate's not as obvious. So you would take your second term, so this one's 16 divided by 54, which equals 1/4. So your rate is 1/4. So what that means is each number is the previous number divided by 4, but we're always going to use multiplication for our rates, so that's why it's 1/4. So this third one, we'll take our 2/9 divided by 1/3, which is 2/9 times 3/1. And you can simplify that to get 2/3. So your rate is 2/3. So the first important formula to know is the recursive formula. So the variable that you need to put in here is the rate, and you will use your previous term to find the next term. So in this example, we need to find our rate. So we'll take our second term divided by our first term, which gives us a rate of 2. So we know a sub n equals a sub n minus 1 times our rate, which is 2. And then we also need to put our first term. So our first term, a sub 1, equals 3. So this would be your recursive formula for this sequence. So in this first example here, we'll find our rate. We'll take our second term divided by our first. 1/4 is our rate. And our first term is 4. So a sub n equals a sub n minus 1 times 1/4, where a sub 1 equals 4. On this second example, we'll take our second term, 1/6 divided by 1/15 equals 1/6 times 15/1. We can simplify that to get 5/2. So our rate is 5/2, and our first term is 1/15. So we have a sub n equals a sub n minus 1 times 5/2, where a sub 1 equals 1/15. Next, we have the explicit formula. For this formula, we'll input our first term and our rate so that we can use n to find a sub n. In this example, we'll find our rate, so our second term divided by our first term, which is 4. And we want to always make sure that our rate is continuing. So 2 times our rate of 4 gives us 8. 8 times 4 is 32. 32 times 4 is 128. So that's good. We know it is a geometric sequence, and our rate is 4. Our first term is 2. So we have a sub n equals our a sub 1. So 2 times our rate, 4 to the n minus 1. So that would be our explicit equation. So if we wanted to know the fourth term, for example, we'd say a sub 4 equals 2 times 4 to the 4 minus 1, which is 2 times 4 cubed. 4 cubed is 64, so we have 2 times 64, which is 128. And that is our fourth term up here. So we'll find the explicit formula of this one. We'll take our second term divided by our first. We get our rate of 1/4. Our first term is 4. So a sub n equals a sub 1. So 4 times our rate, 1/4 to the n minus 1. For the second one, we have 1/6 divided by 1/15, which is 1/6 times 15/1. Which becomes 5/2 is our rate, and our first term is 1/15. So we have a sub n equals 1/15 times 5/2 to the n minus 1. So if we wanted to find our third term here, for example, we'll say a sub 3 equals 1/15 times 5/2 to the 3 minus 1, which is 1/15 times 5/2 squared, 1/15 times 25/4, which we can then simplify. This could be 5, and this is 3, so we have 5/12. And that is, in fact, our third term. Next, we have summation notation, where we want to find the sum of a geometric sequence or series. So for this one, we'll plug in R, A1, and N in order to find our sum. So in this example, we have that our first term, our A sub 1, equals 5. To find our rate, we'll take our second term divided by our first. So our rate is 6/5. And then we don't know the number of terms because there's this ... right here. So to find the number of terms, we're going to write our explicit formula. So we have A sub n equals A sub 1, 5, times 6/5 to the n minus 1. And we want to figure out what number term this last one is. So we have 12.4416 equals 5 times 6/5 to the n minus 1. So we'll divide both sides by 5. Then we get 2.48832 equals 6/5 to the n minus 1. To get rid of this here, we need to do a logarithm. So we'll learn more about logarithms in another video coming up. But for now, we'll just take this and make it the log base. And that will get rid of this here. So we have log base 6/5 of 2.48832 equals n minus 1. So we can use our calculator to find our log base 6/5 of 2.48832. To do this, you go to Math, and then there's something that says log base, and then you'll enter in your base of 6/5, and then 2.48832. So that should come out to be 5. So we have 5 equals n minus 1. We'll add 1 to both sides, and then we get 6 is the number of terms in this series. So we have n equals 6. So our sum of the 6 terms is A sub 1, so 5, times 1 minus r 6/5 to the n, which is 6, over 1 minus r, 6/5. So you can enter that all into your calculator, and you'll get that the sum of this first 6 terms is 49.6496. So here we have our summation notation, where we're doing a sum from n equals 2 to n equals 20. So to find your first term, your A sub 1, we're going to plug in 2 for n. So it's going to be 3 times 1/2 to the n minus 1. So it's not actually A sub 1, it's going to be A sub 2. But this will be our first term for our sum. So we'll plug in 2, 3 times 1/2 to the 2 minus 1, so to the first. So it's 3 times 1/2, which is 3/2. And then our rate is the number right here because it's the base of the exponent. So our rate is 1/2. And our number of terms is going to be 20 minus 2. And then we're going to add 1 because we're including the 20 and the 2. So this is going to be 19, which is our n value. So our sum of the 19 terms equals our first term, which is 3/2, times 1 minus our rate, 1/2, to the n, which is 19, over 1 minus 1/2. And that comes out to be approximately 3. So for this next example, we're finding the sum of the first 12 terms in the sequence. So we know the number of terms is 12. Our first term is going to be 3/11, and then our rate is going to be our second number divided by our first number, which is 6/11 times 11 over 3, which we can simplify down to just 2. So our sum of the first 12 terms is our first term, 3/11, times 1 minus our rate, 2, to to the n, which is 12, over 1 minus our rate. So that gives us a sum of 1,116.8. Next we have our challenge problem. So we have A3 equals 96 and A6 equals 6,144, and we need to find the sum of the first 10 terms in the sequence. So we know that n equals 10, but we don't know A1 and we don't know our rate. So we'll start by creating some equations using our explicit formula. So we have an equals A1 times r to the n minus 1. So we know A3 equals 96. So 96 equals A1 times r to the n, which is 3 because this is our third term, minus 1. So 96 equals A1 times r squared. So we have one equation and two unknowns, so we need a second equation. And so we'll use our A6 value. So we'll say 6,144 equals A1 times our rate to the 6 minus 1. So 6,144 equals A1 times r to the 5th. So we'll solve both equations for A1. So we'll divide this by r squared. A1 equals 96 over r squared. And on this equation, we'll divide by r to the 5th and get A1 equals 6,144 divided by r to the 5th. We can set these two equal to each other. 96 over r squared equals 6,144 divided by r to the 5th. And we can multiply both sides by r to the 5th. So these will cancel. R to the 5th over r squared, you'll take the 5 minus 2 and we'll get r cubed. So we have 96 r cubed equals 6,144. Divide both sides by 96. And then we'll get that r cubed equals 64. So then we need to take the cubed root of 64 and r cubed to find r. So we have r cubed equals 64. And when we take the cubed root of both sides, we get that r equals 4. And then we just need to find our first term. So we'll plug in r of 4 to one of these equations. So we'll go ahead and say A1 equals 96 over r squared. So A1 equals 96 over 4 squared, which is 96 over 16, which equals 6. So A1 is 6. So then to find the sum of the 10 terms, we do A1, 6 times 1 minus r, which is 4, to the 10th over 1 minus 4. And when you plug that into your calculator, you get that it equals 2,097,150. So there are several applications for geometric sequences and series, some of which are the spread of a disease, if a disease is spreading at a constant rate. There's a salary increase or decrease, and then population growth or even population decline. So here's a problem where we can apply our geometric sequences and series. So it says in 2000, the population of bears in the forest was 432. Each year, the population is decreasing by 12%. What year will the population drop below 100 bears? So we have our A sub 1, our initial population is 432. And we also need to know our rate. So our rate, it says the population is decreasing by 12%. So to figure out the rate that the population is changing, we take 100% minus 12%, which will give us 88%. So the population is decreasing by 12% each year, which means its rate that it's changing by is 88%. So we'll change that into decimal and put 0.88 as our rate. So then for our explicit formula, we'll get that a sub n equals a sub 1, 432, times our rate, 0.88, to the n minus 1. So n minus 1 assumes that we're starting with our first term being counted as year 1. So this would mean 2000 is year 1, 2001 is year 2, and so on. But this is kind of confusing because we have 1 being year 2. So if we start at year 0, then it will be a lot easier to calculate. So to start at year 0, what we need to do is just get rid of this minus 1. So a sub n equals 432 times 0.88 to the n. So that means our first term is not actually a sub 1, it's a sub 0. So for example, if we wanted to know what the population would be in 2005, that would now be year 5. So we'd say a sub 5 equals 432 times 0.88 to the 5th. So that would be 227.98. So your population in 2005 would be that much. So to figure out when it drops below 100 bears, we need to know when a sub n is 100. So we'd say 100 equals 432 times 0.88 to the n. We'll divide both sides by 432. So then we have 100 divided by 432 equals 0.88 to the n. And to get rid of this base of our exponent, we're going to turn this and make it into a logarithm base. So it would be log base 0.88 of 100 over 432 equals n. So when we enter that into our calculator, we'll get that n equals 11.447. So that's how many years it's been since 2000. So our answer would be during the year 2011, our population will drop below 100 bears. So during 2011. In summary, we have some important equations here. So for your geometric sequence, you have your recursive formula, your explicit formula, and your summation formula, and all of the variables that you would need here. Thank you for watching.